Okay, we will start with solving a few problems in exercise 9A. So this is the sampling. Okay, so we look at question 5. So X, this has a number. One side is 1, the other side is 5. Right? So the probability distribution for X, number 1 and 5. So the probability is a fair disk, so half. So now, so find the probability distribution of X. We are done. So if we want to find the mean and the standard deviation, you can use your GC or you can use the formula 1 times half plus 5 times half. So I got 3. Right? Then the standard deviation, you can use like that. 1 square times half plus 5 square times half. Take away mean square. So it's square root of 13. So by the way, you don't have to use formula. You can use your GC. So answer is square root of 4. There is 2. Right? Okay, then part C, they say, okay, who can explain what is the meaning of S4? Can someone tell me what is the meaning of S4? Right? Sample of 4 is S represents sample. Yes, correct. Sum of the number shown in, this is one flip. This one, 4 is what? This is single flip. Correct? So this one, so you flip the this how many times? Hello? You flip the this how many times? Ashley?
4.
How many times? Yes?
4.
Shown in 4 flips. Right? So now find the mean and the standard deviation. So do we need to build the probability distribution table? Do we need to build a probability distribution table for this case?
Can just use the formula, right?
Yeah, we can just use the formula. Thank you. We don't have to build. If you want to build also can, you waste your time. It's exactly like in your SAT. Some of your, when you find the value, okay, you go and integrate. You're wasting your time. So this one, you have the formula. So the mean of S4 is equal to, okay, can someone tell me what to multiply with what? Hakim? Hakim? What to multiply with what? You see, you follow this formula. N, this is your N. You see or not? Your N is here. So my n is 4. And the mean of x is here. That is 3. That is 12. Okay, how about the standard deviation of this sum of the sample of 4? 4 flip will be square root of n. Okay, square root of 4 times by the standard deviation of this one. That is 2. So answer is 4. If you don't trust this formula, then you go and build the probability distribution table then and see. Right? Hello? So may I know what are the possible value for S4? Can anyone tell me what are the possible value for S4? Sum of the numbers shown, sum of the numbers shown in 4 flips. Can you tell me the possible value? Hello, can you please answer? Okay. One of your friends said 2, 3, 4. Agree? Hello, agree or disagree? You agree, you say something. You disagree, you say something, can or not? 4 is one of the possible, but not 3, not 2. Why? This is wrong. This is not. Because you say 4 flip. So 4 flip, what you can get is you can only get 1, 1, 1, 1. So you add up. Or out of the 4 flip, 3 is 1 and the other one is 5. So the next number is 6. Out of the 4 flip, 2 is 1 and 2 is 5. So the answer is 12. Well, I can convert this on, ask you to list out all the possible value for S4. Then 1, 5, 5, 5. That is 16. Then the other 4 all are 5. That is 20. So how to find the probability? So the second row is 8. Yes, thank you. You get me? Hello? Hello?
Oh yeah, it makes sense.
So makes sense. So now how am I going to find the probability? If I'm nasty during exam, Then how are you going to do? How to find the probability? The last one is 20, okay? So the probability for this one is 1 to the power of 4, correct? This one is also 1 over 2 to the power of 4, but I times with what? You see, out of the 4, you got 3, 1. So the way will be 4C3. 4C3 is what? 4. So you type the 4 here. So here will be, then out of 4, you got 2. 4C2. What is 4C2? 6. Then here is 4C1. And here is 1 over 2 to the power of 4. So can I turn this question into ask you to build a probability distribution table for S4? Can. So I can put this combined with your chapter 7, which is talking about discrete distribution. Are you clear? It can be done in that way, okay? So, are you clear? So this is something extra. They can ask you to build. Okay? So part D. Okay, they say find the mean and the standard deviation. This one just follow the formula. The mean of S50. So you just follow the formula 40 times 3, 50 times 3, 150. The standard deviation of S50, that is how you denote. Right? That is square root of 50 times 2. That is 10 root 2. Okay? You can use your calculator to count. Are you okay? So this is how, when to use formula, when to the one. Okay, so can we go to question 7? So X is the weight of a hot cross. That means weight of one hot cross. Okay, this one, the mean weight of one hot cross is 80. So this is your population. Okay, 8 gram, 80 gram. Hot cross bun. What is hot cross bun? A type of bun, is it? Never eat before. And the standard deviation for X is 5 gram. All right. So now I have a bag. Inside the bag, I have 6 hot cross bun. Okay. So that's why they say S6 is the weight of a pack. This question is very nice. In the real exam, we will say in a pack there are 6 hot cross bun. So find the mean weight of the bag. They won't tell you S6. Weight of a bag of 6 hot cross bun. So they will ask you to find the mean weight. Of a bag, a packet of hot cross bun. They will ask you like that. So that means you are finding. So the formula follow N, this is your N times 80. So 6 times 80, 480 gram. So what is the standard deviation for this bag? The weight of a bag that consists of 6 hot cross bun, it will be square root of 6 times 5. So you use your calculator and count, you get the gram. Hello? So they won't tell you S6, you have to know. They will say the weight of a packet, 12.2. Thank you. In the real question, they will say the weight of a pack of 6 hot cross bun. Find the mean weight of a pack of 6 hot cross bun. Okay, they won't tell you that at 6. You have to know that. If I give you a pack, that means each packet is a sample. Clear? You must have this in mind. Can or not? Okay, so that will be about this, the formula. Okay, now let's go to the distribution of sample mean. Yeah. We want to talk about sampling distribution of sample mean. Okay, so what is the variable for this? Okay, sampling distribution of sample mean is the distribution of sample mean for all possible sample of sampling distribution of sample mean is the distribution of sample mean of a given size from a given population. All right. So just now we talk about the pumpkin, right? Yeah. So the given size that we have is, what is a given size? So if I put like that, I put X, the weight of a pumpkin. Okay, so if I put X bar 30, so how you talk about this? What is X bar 30? How you describe? Is the sample mean X bar 30 distribution is the sample mean, is the distribution of sample mean of how many pumpkin? Of how many pumpkin? 30 pumpkins. For all possible samples. I don't have to put a given size because I said 30 pumpkins already. Distribution X bar 30 distribution is the distribution of sample mean of 30 pumpkin from all possible samples that are drawn from Mr. Rick farm. Correct? So you understand, you have to learn how to know how to say the distribution. Yeah. X is the distribution of the weight of all the pumpkins produced in Mr. So this is the population. Okay. So according to CLT, central limit theorem, if X, the mean of X is A, the standard deviation of X is K. So the X bar 30 is what? What is the distribution of X bar 30? According to CLT. Hello? Is what? Huh? Is what? Muhammad Amali? How is the distribution of X bar 30?
Normally distributed.
Yeah, X bar 30 is normally distributed. Okay. With the mean for X bar 30 will be equal to what? The mean of the population, that is A. And the standard deviation of X bar 30 will be equal to the standard deviation of the population divided by square root of N. So in this case will be K over square root of 30. Clear? So this is what it means by sampling distribution. So when you talk about sampling distribution, you have to talk about what you want to talk about. So X bar 30 distribution is the distribution of the sample mean. Of what? Of 30 pumpkins. So this one is the sample size. For all possible samples that are drawn from where? From this is your population. Clear? So then you say, according to CLT, it gives us the nature of the sample mean distribution. Are you okay? Okay or not? Okay, so now Ms. Noor is going to illustrate all this and try to explain here. So when you do your folio, correct, you have justified a claim, then you have choose a sample, correct? You choose a sample size, then you talk about this, then you say according to CLT, this have this distribution. Then after that, the later part it will come in. So at the beginning of your folio, afterward I will release the folio in your times. Okay, you can go to you can start to think about that. By next week you should be able to have some idea what to do, and I have load in some samples of my previous students, the A students and B and so on and so forth. Let me see which chapter am I, which topic I put into which topic. Hold on. I put in topic 8. So now I let you view the question first before I let you view the sample. Okay? The sample, I don't want to let you view first. Yeah. Okay, you can have a look at the question. Yeah. So because in the question, they got say about the parameter and so on and so forth. Okay. If you got time, don't wait until last minute. You have to submit to me. You have to submit to me the folio by the end of August. So you don't have much time. So I'm trying to kill two birds with one stone. Teach you for SAT 6 as well as writing the folio. Yeah. So I'm teaching according to the structure how you should write your folio. Okay, Anna? So claim. So just now the first lesson we are talking about why we need to take sample because the population is too big. So if we want to study about the mean of the population, correct, it's impossible. So we do sampling. So what is sampling? Sampling means you're taking samples after samples, after sample, after samples, after sample, until you get all the possible sample. And each sample you find either the mean or the sum, up to you. Depend on what you want to talk about. Yeah, the mean. Okay, then for each sample you find the mean. Then according to CLT, he said if our sample size is large enough, our sample mean or sum of the sample distribution will be normally distributed. And this is a relationship. In real life, later I will tell you, it's not from population to sample. Actually, it's from sample mean distribution, we go to the population. Yep. Okay, so that is the rough idea, the way how you are going to begin your writing of folio. Okay, so now let's look at 9B. Okay, I want to say something. Okay, number one, they say a random variable X. So that means this is your population. The moment they say a random variable X, that means this is the population. Some population are okay. So this is a population. So the mean for X is 20. You see how Mr. write? Mean standard deviation for the population is equal to 6. Yeah. So now find the mean and the standard deviation of. So now, part A. What do you mean by X bar 4? What do you mean by X bar 4? What's that? Is what? The mean is the sample mean of all samples of size for that are drawn from the population of variable X. correct? So X bar 4, I also can say that this is the population of sample mean of size 4, correct? So according to CLT, okay, will it be normally distributed? I don't know, correct? So that one I cannot say because, okay, 4 is less than 30. So that means my X bar 4 may not be, my X bar 4 distribution may not be normally distributed. I don't know. Okay? Because by time of, because I don't know how big is the population in the first thing. Okay, it may not. So I say may not be normally distributed. Same go with X bar 20. Because by time of rule, my X bar 30, X bar, the sample size must be more than 30. But I can count the mean of this population. My population is what? The variable is sample mean. So you see, I write down my variable. So what is the formula? Brandon?
Hello?
What is the formula? What is
4
the,
times 20.
huh? Salah lo. That is SNO. Brandon. This one. When you talk about mean, you have to remember this. Can or not? When you talk about sum, you have to remember this. So do you see the difference? This one, the variable is the sum. Understand? Sum
Yep.
means total. Yeah. Everyone, you have to be very careful. This one, you every sample you take already, you count the total, then you divide by 30. So you are talking about the sample mean. This is your variable. So you have to go follow like that. Can or not? Hello?
Yeah.
Please, if not exam, you should kalang kabut one. So get that right. Okay? So according to CLT, okay, because 4 is less than 30, it may not be normally distributed. So then is equal to the population mean. So equal to 20. Am I right? So the standard deviation of this variable of mean is equal to the standard deviation of the population divided by square root of n. 6 divided by square root of 4. So answer is 3. Can or not? So for B, do the same. Try to explain. Put in words. What do you mean by X bar 4? Don't just say X bar 4, X bar 20. You must be able to put in words, right? So X bar 20, yeah. Can you put in word? I think I don't have to teach you how to put in word already, correct? So the mean for x bar 20 will be equal to the mean of the population. So it will be 20. The standard deviation of x bar 20, because you take a bigger sample size, so the mean should be much closer to each other. So it's equal to 3/√5. So it's 3√5/5. Are you okay? Okay. So the rest, I will leave it to you. And I will want to talk about, hold on. Okay, the rest you can just follow the formula and get the answer. Okay, I want you to go to, okay. Now, 9C. 9C, this one, we are going to do calculation. Okay, now, 9C, let's start with okay, let's start with question 1 first. Okay, I have my x is a random variable. The mean of x is equal to 70 and the standard deviation of x. Can you follow? So I have 64 observation. X bar 64 means the mean, the sample mean of all the samples of size 64 that are drawn from the random variable x. Okay, now they say find the mean and the standard deviation of this one. Okay, so is x bar 64 approximately normally distributed? Explain your answer. So how are you going to explain your answer? So part A should be no problem, correct? The mean of x bar 64 is equal to the mean of the x variable. Am I right? According to CLT. So it's equal to 70. The standard deviation for x bar 64, that means the sample mean of sample size 64 is equal to 12 divided by okay, just sing. Just sing. Divided by what?
Square root 64.
Yeah, thank you. Square root of 64. That is 12 divided by 8. Yeah, So if, okay, so if you didn't get a, okay, the one I talk about later, don't talk so much first. Shh. Okay, so this is 3/2, all right? So now part B, they say, is X bar approximately normally distributed? Explain your answer. So who want to try to explain? Who want to try to explain? Just now I told you CLT, correct? So every time we tap onto this powerful theorem. Okay. Huh? Want to try to explain? Amali, may I know where is your brother Uma? Oh, she is there. Okay. Two of you. Okay, who want to try to explain? Quick. You're wasting your time. Yes. You see? So according to CLT, if n is greater than or equal to 30 by thumbs of rule, okay? So 64 is more than 30, right? So therefore, the distribution of X bar 64, the distribution of the sample mean of sample size 64 will be normally distributed. Are you okay? Okay, so since the distribution is normally distributed, so if I want to find the probability that the mean will lie between certain value, what should I use? I should use normal distribution, correct? Am I right? Even the SN also the same thing. Yeah. Like number 3, if you look at number 3, is S5 normally distributed? No. Why? Because the N is less than 30. Correct? So that is how he talk about. But, okay, number 3. Everyone go to number 3. Everyone go to number 3. He say a random variable X is normally distributed with a mean of 50 and a standard deviation of 9. So be very careful. If the population is normally distributed, so whatever sample size it doesn't matter. The X bar N will be normally distributed. With smaller spread. Are you clear? Look, if the population is not normally distributed, then I have to go by this rule. If it's normally distributed, the sample mean definitely will be normally distributed. Are you clear? So they say, is S5 normally distributed? The answer is yes, because X is normally distributed. Do you get me? So that is what question 3. So when you talk about central limit theorem, the n greater than 30 only apply if the population is not normally distributed. Are you clear? Can or not? Okay or not? So okay, so have to remember this rule only apply if I don't know the distribution of the population. If I know population is normally distributed, this 100% is normally distributed. Clear? Okay. Can I move? Okay, now I want to go to question 4. Say, suppose X is the mean, X has the mean of this. So find the mean. So now I want to change from X to, okay, so now I want to talk about the distribution of X bar 36. So can I say this is normally distributed? Yes or no? Can I say X bar 36, the mean of the sample mean of sample size 36 variable is normally distributed? Can I say that? Can, because 36 n equal to 36 is more than 30. So the mean will be equal to 80 and the standard deviation will be equal to 9 over square root of 36. So it's 9 over 6. Yeah. Okay. So now, so I explain the idea, part B. Okay, part C. So now, that means now I have this X bar 36 distribution. It's normally distributed. So the moment you say the thing is normally distributed, you want to find the probability. Okay, now can I have someone put this in word? Can I have someone put this in words? You are finding the probability that the what? The X or the sample mean? So how can I use this to count? How am I going to count this? You're very quiet. I'm talking to the whiteboard. Am I right? Sure, I'm right. I don't think I'm right, lor. I purposely write one number which is wrong. Who can tell me what number is that? I'm talking about this. Can I take the standard deviation of this? So you have to, now you have to be very, very careful. What are you talking about? Which variable are you talking about? Are you talking about the variable of the population, or are you talking about the variable called sample mean? See or not? I'm not talking about individual variable, random variable X. I'm talking about, I take a sample of size 64. Every sample, I count the sample mean. What is the chances that my sample mean that I take will lie between 75 and 81? Are you clear? So this are question you can like part 2 is say, okay, what is the chances that a sample mean will be greater than 82? What is the chances that a sample mean will be less than 79? See or not? So these are called probability. Are you okay? So in this part of the chapter, you have to know what is your variable, what is your parameter that you are going to discuss. Variable, the parameter. Are you going to talk about the individual of that population, or are you going to talk about the whole thing? Can or not? Okay, I just want to let you know, exercise 9C, correct? Question 6. Don't have to do. Okay, you don't have to do question 6. Are you clear? You can look at example 5. Then I will try to discuss more example tomorrow. Can or not? How we apply this in a real life situation. Yeah. So next week I will get into confidence interval. Then by next week I will finish everything with it. Ha! Take a deep breath first. Okay, thank you, class. 2 of your friends have to run for their test now.
Thank you, Miss.
Yeah.
Thank you, Miss.
Yeah.
Yes.
Yeah, 2 of you log in.
Thank you, Miss.
Yeah, you log into the other one.